Alright, so this will be our first video for the semester. Basically, my videos will kind of work, they all work kind of the same way. Essentially, I've written, I guess you might call it a text. And the text is broken up into chapters, and the chapters are broken up into sections. And for each section, the beginning of the section will have some explanation of the concepts that are required to understand the homework in that section. And I'll kind of just go through the concepts, and once I've gotten through enough concepts that we have enough knowledge to do some homework, then I'll start doing homework. And every time I do a homework problem, I'm going to put two problems on the screen if two problems will fit on the screen. And I will do the even numbered problem that I put on the screen, and I'll ask you to do the odd numbered problem that I put on the screen for your homework. So theoretically, you should get done with all your homework as you're watching the video. You shouldn't watch the video and then wait an hour or two, then do the homework. Just kind of be interactive as you're going through these videos, doing the homework as you're doing the videos. At the end of every section, the very last page in every section are going to be the answers for all the odd problems in the section. And I'm going to do all the even problems. Doing the even problems should help you learn how to do the odd problems. And you should check your answers to the odd problems. On most of the videos that I do, I flash up the answer after I ask you to do a problem, so you won't have to check too often. They'll mostly be appearing on the screen, but I think sometimes I forgot to flash the answers up. Some students just have the desire to print out everything that I've written, and that's a complete waste of paper. I'm going to go through lots of definitions in our class, and I'm never going to test on a definition. I'm only, when I write my test, I create problems that are like the homework problems, and this is really all you should be printing out. So, although this link right here that says problems and answers will have the problems, answers, and it will have all the theory in the section. Printing this out might be a bit of a waste. If you kind of scroll over where it says miscellaneous problem with space for tablets, if you open up that link for every section will have just the problems, and and the problems have a little bit of space. If you have a tablet, you could use your tablet and not have to print out anything if you open up these documents. Or if you're going to print something out because you want to print out the problems, if you print that out, it will give you all the problems in a section with some space to work, and it will save you a lot less. You won't have to waste so much paper. So let me just get started with this section. If there's anything that I kind of mumbled through right now that's a little bit confusing for you, just yell at me and we'll make it better in class. So I went to grade school in the 70s, and just about everything that we do in chapter 1 I learned in grade school, because set theory was the new math in the 70s, at least in the 70s in Ohio. But because most students weren't alive in the 70s, you may have never seen any of the concepts in this chapter. I promise you there shouldn't be anything that's hard. If I do a good job lecturing, this should be a really easy chapter for you. So I'll kind of get started. So the whole chapter's on sets, and I'm just going to read through as much as I can tolerate what I've written. A set is just a collection of objects. And each object in a set, I'll use the word element or member to name the objects in a set. So a set's just a collection of objects, and usually we give sets names, and a set is usually given a capital letter name. And now I just wrote an example. Maybe I'll pull out a highlighter here. So I said let A be the set, so it's a collection of objects, of integers between 2 and 5 inclusive. There's a ton of words there that you may not be familiar with to even understand what that sentence means. So I need to talk through that with you. And then I said, list the elements of set A and place the elements in set braces. There's a lot going on in this little example to help you understand what a set is. So first of all, I'm going to write a the elements of set A, and I'm going to write them in set builder notation. So the first thing, the set that we're dealing with is set A. So I'm going to list the elements of set A because this is what I'm asked to do. I'm going to list the elements of set A and place the elements in set braces. So here is the name of the set. I'm going to say set A equals, and these curly brackets are called set braces. So I'm going to, inside these set braces, I'm going to list the elements of set A, or the objects, or the members of set A. And the objects are numbers. They're specifically integers. And integers are essentially numbers without decimals. Integers are positive and negative numbers, like -3 is an integer, -2 is an integer, -1, 0, 1, 2, and they get bigger, they go up to positive infinity, and they get smaller, they go down to negative infinity. So when I said let A be the set of integers, the kinds of elements or the kind of members of set A are these kinds of numbers. And specifically, set A has integers between 2 and 5, and then it has the word inclusive. In our class, we're going to use the word between a lot, and sometimes when we say between, we'll include the numbers that are mentioned, and other times that we say between, we won't include the numbers that are mentioned. This set A, it says I'm choosing A to have the integers between 2 and 5 inclusive. This means to include the 2 and the 5. So set A, I'm naming it, putting the elements are the numbers that are in the set inside the set braces. Set A is going to contain the elements 2, 3, 4, and 5. These are all the integers, which are numbers kind of without decimals, between 2 and 5, including the 2 and 5. So that's what this example asks me to do. And a lot of what I have written here is some more explanation about what sets are. I'm debating how much to say and how much not to say, because I've written a lot, and we don't need everything that I have written to be able to do the problems. And sometimes saying everything that's on my mind makes the problems more confusing than they need to be. So I think for this first page, this is all I'm going to say. There isn't really anything I have written under here that isn't either something that I've already said or something that is just not that important that we need to worry about it. One thing that is mildly important, I'll flip on to the next page, because on the next page there's something that I said, written on here that's kind of essentially important. So on this page, which is kind of my second page, it's not likely the second page, I just made this big enough so you could see it, but I talk about what integers are. I show you that the integers are the numbers with positive and negatives without decimals. I describe what the word inclusive means. Inclusive means to include the first and the last numbers that are described. And then I wrote the set using the set braces. And notice I wrote the set here with the numbers going from smallest to largest. This is not absolute. When you're listing the elements of a set, it's not really important the order that you write the elements in, and that's kind of what it says down here. I took the time to write A in kind of the natural order, but I didn't have to. And when I answered that example to list the elements of set A in set braces, I could have done either of these two choices. I'm sure there's other choices. So when you're listing the elements in a set or the members of a set, usually we give the set a capital letter name and we put the elements or the objects or the members of the set in these curly braces. I usually put the elements in, if they're letters, in alphabetical order, in numbers in numerical order, but it's not a deal. If you write them in a different order, these three sets are all equal to set A. They all have the numbers 2, 3, 4, and 5. The example that I did used the word inclusive when I talked about the integers between 2 and 5. Sometimes in this section, we're going to use the word exclusive instead of the word inclusive. Inclusive includes the numbers mentioned. exclusive doesn't include the numbers mentioned. And so when the word exclusive is used in a set description, the first and the last number given are not included when we write the elements of the set. So let me take that same example that we just looked at on the last page and do that slight tweak, change the word inclusive to exclusive, and show how that kind of impacts our answer. So let A be the set of integers between 2 and 5 exclusive. List the elements of set A and place them in set brackets. So if I want to list the elements of set A, I usually want to say the name of the set. So set A equals, and I'm going to put them in these set braces, which are these curly braces. And the elements that I need have to be, that go in here, are integers between 2 and 5, but not including the 2 and 5 because of the word inclusive. So these are the candidates for the numbers between 2 and 5. If it was between 2 and 5 inclusive, I include the 2 and the 5, but for this set A, I'm only listing the integers between 2 and 5 exclusive, so I'm not including the 2, I'm not including the 5, I'm excluding as opposed to including the 2 and the 5. And so this would be the set A that is we need here. Of course, I could have written set A as the set containing the numbers 4 and 3. My set braces will get progressively worse. This is what set braces are supposed to look like, but I must take any kind of squiggly bracket over here. It doesn't have to be perfect. So I'm going to do a few more examples, some trickier than the others. So let's look at, I should probably cover up my work down here so I'm not spoiling the surprise. So let B be the set of solutions to the problem x plus 5 equal to 8. List the elements of B and put it in set braces. So my answer for this has to be the name of the set is B, followed by an equal sign, and then I'm going to list the elements of set B and put them in my set braces. And the elements of set B are the solutions to the equation x plus 5 equals to 8. Well, in order to figure out what the elements of set B are, I need to find the solution to x plus 5 equal to 8. That's pretty easy to do. We're never going to factor in this class, but we might solve some simple equations. If I solve that equation for x by minusing 5 from both sides, I get x equal to 3 as the solution to that equation. And so the only element in set B is the only solution to that equation, which is the number 3. So B is the set that contains the number 3. And that's all that this says. The rest of this sheet here just says I need to do a bit of algebra to find the elements of set B. I do the algebra. I say 3 is the only element of set B, and I write my answer. Now we're ready to do our first chunk of homework. It's the first 8 problems in this section. And I'm going to do problem 2. I'm going to ask you to do problem 1. And I'm going to show you your answer for number 1 so you can check. So the instructions say list all the elements of the set below, write your answer in set braces. So for my question 2, A equals a set of odd numbers between 1 and 10 inclusive. So let me list all the odd numbers between 1 and 10. The odd numbers between 1 and 10 are 1, 3, 5, 7, and 9. And set A, when I go to write down what set A is, I'm going to write the letter A, followed by my set braces, and I'm going to put all the odd numbers between 1 and 10, and I'm going to include the 1, and I would include the 10 if it was an odd number. So these numbers that I've listed are all going to be included in my set A. Hopefully this inspires you to do problem 1. Your set A for number 1 that you're going to list in set braces are all the even numbers between 1 and 10 inclusive. And the answer that I have written down for your problem 1, A has the numbers 2, 4, 6, 8, and 10. Of course, you could have written 10, 8, 6, 4, and 2 if you wanted to write it in an odd order. All right, time to work on 3 and 4. You don't even need to watch me do 4. You can fast forward if you want. As a matter of fact, let me show problems 3, 5, and 7. If you think you can do problems 3, 5, and 7 without watching me do 4, 6, and 8, do 3, 5, and 7. Let me flash the answers up here. for the answer to 3, the answer to 5, the answer to 7, which might be a tricky question. And then if you've got all those done, don't watch me do the problems I'm going to do, and skip to the next section of the video after I finish problem 8. So let me just real quickly work through problem 4. B is a set of odd numbers between 1 and 10 exclusive. The odd numbers between 1 and 10 are 1, 3, 5, 7, and 9. Because 4 has the word exclusive, I'm going to exclude the 1 and the 10. The 10 isn't an odd number, so it excluded itself because it's even. The 1 gets excluded because of the exclusive word. My answer to part B is going to be the set that contains the numbers 3, 5, 7, and 9. For year 3, just in case, you're going to have 2, 4, 6, and 8 for your answer. There's kind of no work to show there. For my problem 6, set A is a set of solutions to the problem x minus 4 equals to 9. I'm going to solve this problem for x, and then I'm going to write the answer to that in set braces, and that's going to be the only element in set A. So I solve this equation. For my answer to question 6, I'm going to say A is the set that contains the number 13. For your problem 5, you should probably say A is the set that contains the number 4. And again, my set braces get progressively less like set braces, but I'm never going to take points off if they're not, even vaguely close. So this is your question 7 was in some sense tricky, because if you don't know the flavors in Neapolitan ice cream, then you couldn't list set B. Your answer to question 7, set B is the set that contains those 3 flavors of ice cream. Those are the flavors in Neapolitan ice cream. Never on a test would I ask something that you need special knowledge for. I'd ask things with numbers or things that are real common knowledge. My question 8 wants to list the set of the days of the week. Let me just be lazy and abbreviate. I'll say Monday, Tuesday, Wednesday, ... Sunday. This is lazy. This ... means the pattern continues, and I think I established a pattern here: Monday, Tuesday, Wednesday, then Thursday, Friday, Saturday to Sunday. That's a lazy way to write that answer, but I didn't feel like writing Thursday, Friday, Saturday in there for whatever reason. So if I can see a pattern, and you can put ... because you don't want to list everything that needs to be listed, this is fine. So I started the days of the week, I put ... meaning this pattern continues, and it continues and it ends on Sunday. That's a completely fine answer. Or I could have listed all the words Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So that's the first part of the section, but not the whole section. All these sections are kind of long in chapter 1. The next part of the section, we can't do the homework before we get a little bit of theory. And the next theory talks about sets being well defined. So what does it mean for a set to be well defined? A set is well defined if any objective person can decide if a given element is in a set or not. This definition is a bit abstract because there's a little opinion here on what a well-informed objective person might think. But usually, sets defined with words like good, bad, nice are indicators that a set is not well defined. So for the next few problems, I will do some examples. So example, let M be the sets of months with more than 30 days. Is this set well defined? My answer is either going to be yes, it's well defined, or no, it's not well defined. And for most people would probably know the answer whether this is well defined or not, but let me talk through it just in case you don't. The question would be, is it, if I give you a month, is it going to be clear whether that month is part of this set or not? Like if I give you the month February, can you tell me if February is going to be in this set or not? Well, February has 28 or 29 days, which is not more than 30 days, so February is not going to be in this set. If I give you the month of January, well, if you don't know how many days January has, you can pull up your cell phone calculator or your cell phone calendar and figure out January has 31 days. 31 is more than 30, so January is part of this set. If I give you the month of June, which has 30 days, June's not going to be in this set because to be in this set you have to have more than 30 days. So I think this set is well defined because if you give me any month, it's pretty clear whether that month belongs into the set or not. Only the months with more than but not equal to 30 days belong in the month in the set. Only the sets with 31 days belong in the sets. So I'm saying this set's well defined because there's no ambiguity as whether a set belongs to the month or not. So this set, those are the months that it contains. And in my answer, I said the set is well defined. I got really lazy when I started doing the answers to my homework. Instead of saying the set is well defined, I'm just going to answer the question yes or no. Is the set well defined? I'm going to say yes. I could say yes, the set is well defined. But I could take a yes/no answer for these problems when we get to the homework, or you can write the set is well defined or the set is not well defined. Here's another example. List all the set of good cell phones. Is this set well defined? Well, I had a Samsung Galaxy that I flashed up here, and my sister would say that cell phone's a piece of junk because she's sold on iPhones, and so she would say that's not a good cell phone. I like it because it takes good pictures. I'd say it is a good cell phone. There's some debate. Anytime there's a word like good, bad, or nice, that's usually an indicator that a set's not well defined because different people might have different opinions, and those words are more opinionated words. So I'd say this is not well defined because whether a cell phone is good or not likely depends on who's asks. So my answer, I said the set is not well defined. I could have, and I will start when we start doing the homework, just say no, the set's not well defined. So now we're ready for some more homework problems, and we're going to run through these really quickly. Each of these problems is going to be, for me, let's just do a yes/no answer. Each of the questions between 9 and 16, which I'm trying to slam all of these on the screen right now to save you a little bit of time. It says, which of the following sets are well defined? Write yes for your answer if the set's well defined. Write no for your answer if it's not well defined. So I'm going to go through my questions. 10, set B is a set of GCC students whose GPA is 3.0 or higher. If I can pull up, I'm sure I could do some sort of Excel spreadsheet and put everybody's GPA on there, and it should be clear if a student's GPA is 3.0 or higher. Basically, if you give me a student, I can find out their GPA, or somebody can find out their GPA. If it's above, it's 3.0 or higher, they're in the set. Otherwise, they're not in the set. For your question 9, whether a dog is goofy or not, that's a matter of opinion. Your answer probably should be no. For my question 12, C is a set of good students. Again, that's very objective, so I'm going to say that's probably a no. Your set D, the set of numbers whose square is 16, that's a mathematical problem. The set of numbers whose square is 16 is just the answer to the equation, what number squared is 16. And you might remember how to solve that, but hopefully you know that it's very clear whether a given number is a solution or not. If I gave you the number 3 and I said, is 3 an element of the set? Well, you'd square it. 3 squared is 9. It's not part of the set. If I gave you the number 4, 4 squared is 16. It is part of the set. So the answer to your question 11 is going to be a big yes. I'll let you go do 13 and 15. I'll do 14, the set of Great Lakes, Ontario, Erie, Michigan, Huron, Superior. This is well defined. I could just look at a map to list those. And then I snuck for 16 the set of good smartphones in there again. I'll write down the answers for your 13 and 15 just so you can kind of check your thinking. I think 13 is going to be a yes. 15 is going to be a no. So the video's getting ready to do a hiccup. There it did its hiccup. Every 24 minutes and 15 seconds my videos hiccup. Sometimes I won't catch it and I'll be talking and there'll be a little jump in the video. So next concept before we could do some more problems are finite and infinite sets. A set is finite if possible. Given enough time, it's possible to write down every element in the set. A set is infinite if it's not finite. So let's do an example. Is this set A, which has the sets numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 20. Again, I established a pattern. I put ... to 20. Is A a finite or infinite set? It's finite if it's possible to list down all the elements. Well, it was possible, but I didn't feel like listing them all down because I would just had to write the numbers between 1 and 20. So A is considered a finite set because it's certainly possible to list all the numbers in set A. Oh, the 3 periods in this definition are called ellipses. I didn't know that. I looked it up because I wanted to sound smart. And again, these ellipses or these ... means you continue with the established pattern, the pattern that was established. So there it is. It was A as a finite set because it was possible to write down all the numbers, the elements, members of set A. So A is a finite set. All right, moving on to the next example. Is set B that has the numbers 1, 2, 3, ... but no ending number a finite or infinite set? When I put the number 20 at the end, that means to stop at 20. This ... means to blow right past 20 and keep on going. B is going to be an infinite set because it goes on forever and ever and ever. No matter when I stop writing, there's going to be a next number because these ... mean to continue the pattern, and because there isn't a number after the ... it means to continue the pattern and never stop. So B, it's never going to stop. It's going to be an infinite set because no matter how much I write, there's still more of B because I'm not told to terminate B. So B is an infinite set. My answer here is going to be B is an infinite set. All right, so now some sneaky problems. So determine whether the set is infinite or finite. Set A contains the factors of 10. Factors and multiples are different. I think I sneak both of those words in here. What are factors of 10? Factors of 10 is any number that divides evenly into 10 without, a remainder. Like 2 is a factor of 10 because 10 divided by 2 is 5. 10 is a factor of 10 because 10 divided by 10 is 1. I guess we can be sneaky and say negative 2 is a factor of 10. So some of the factors of 10. 2 is a factor of 10 because 10 divided by 2 is 5. I'll say negative 2 is a factor of 10 because 10 divided by negative 2 is negative 5. So as long as I'm not getting a remainder when I do the division, that number is a factor. The question is, are there infinitely many factors or are there finitely many factors? And if it's possible to list all the factors, then it's finite. If it's impossible, it's infinite. And I was clever. I was just able to list all the factors. 1, 2, 5, and 10 are kind of the only numbers that divide evenly into 10 that are positive, and then I snuck the negative ones on there too. So the factors of 10 are these 8 numbers. There isn't any other number that you can give me that if you divide 10 by it, that you get a non-remainder or a non-fraction. So since I'm able to write all the elements of set A is finite. And so my answer to this, A is a finite set. The next problem uses the word multiples, and multiples and factors are very different. So determine whether the set is infinite or finite, the set of multiples of 4. The multiples of 4 are all the integers times 4. So 4 is a multiple of 4. 4 times 2, which is 8, is a multiple of 4. 4 times 3 is 12, which is a multiple of 4. The multiples of 4 is not a finite set. The positive multiples of 4 would be like 4, 8, 12, 16, 20, 24. I can multiply any integer by 4 and get a multiple of 4. So I can go ... and that pattern is going to go on forever in the positive direction. It also would go forever in the negative direction, but I don't really need to worry about negative multiples. This is enough to tell me that this is an infinite set. And I'm sure this is what I start to write down. We need to know what it means to be a multiple of 4. The multiples of 4 are any number that 4 divides evenly into, or it's any 4 times any integer. And here's the positive multiples of 4. The pattern goes on forever. It's impossible to list all the multiples of 4, so this is an infinite set. Ready to do some more homework. questions. Let me try to, again, throw them all up, as many as I can get at the same time on the screen, just so that if you're feeling good about this, you might be able to just rip through them all. So lots of words, factors and multiples. So let me look at 18 real quickly. Determine whether the set is infinite or finite. The set of factors of 24. These are numbers that divide evenly into 24. I won't worry about the negative ones. 1, 2, 3, 4, 6, 8, 12, and 24 are the positive factors of 24. Factors are always going to be a finite set because there's only going to be there's only certain numbers that can divide evenly into a number without leaving a remainder. So this is going to be a finite set. Your problem 17 is also going to be a finite set because the only factors of 12 are 1, 2, 3, 4, 6, and 12, I think. But factors are generally finite sets. Multiples are usually infinite sets, but not always. Sometimes I sneak some extra words to make that not the case. For my problem 20, the set of multiples of 5, I can just do the positive multiples of 5. The positive multiples of 5 are like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It goes on forever. So just the generic multiples of 5 is an example of an infinite set. Your problem 19 is going to be an infinite set as well. For the same reason. You would have like 3, 6, 9, 12, 15, and 18. You don't need to list the numbers. You just need to say whether it's infinite or finite. Now the sneaky questions. 21 and 22. My 22 is a set of multiples of 4, so let me start writing down the multiples of 4 again. 4, 8, 12, 16, 20, 28, I forgot 24, 32, 36, 40, 44, 48, 52. These are all multiples of 4. My set only contains multiples of 4 that are greater than 10, not including the 4 and the 8, and less than 50, not including the 52. This is actually a finite set. It's possible to list all the multiples of 4 that are bigger than 10 and less than 50. These are the only numbers. In general, multiples make an infinite set, but if I'm only looking at a specific group of multiples, that makes for a finite set. The answer for my 22 is that this is going to be a finite set. When you go to do problem 21, it's the same sort of idea. I'm looking for positive multiples of 4 that are less than 30. So when you're considering numbers for your set, you're only considering positive multiples of 4. Oh, maybe 0 is, I don't know, 0 is not really positive or negative. Maybe we can debate whether that should belong in this set or not, but that's not a debate worth stressing over here. Those are the positive multiples of 4 that are less than 30. And there's this as another finite set. So your problem 21 is also going to be a finite set, just like my problem 22. 23 and 24 talk about positive integers. My set in 24 wants to be the set of odd positive integers. That would be like 1, 3, 5, 7, 9, 11. This set will go on forever because positive integers go on forever. This is going to be an example of another infinite set. Your 23, I imagine, is another infinite set. All right. Getting closer to the end, but there's a few more concepts that we have to deal with. And the empty set is kind of a sneaky little concept that doesn't come up that often, but it comes up every now and then. And I don't want to get too crazy with the empty set. There's some stuff that I wrote in here about the empty set that I might skip over because it's more confusing and it's not very important. But anyways, the empty set is a set that contains no elements. Some texts will call it the null set, but that's rare. The empty set is either given that, which is empty set braces. That would be an empty set because it's a set with no elements. or a 0 with a line through it both mean an empty set. So this is a way to write an empty set without using the set braces. This is very common. A 0 with a line through it when we're talking about sets is automatically a set with no elements, which is the empty set. Here's an example of an empty set. The set A is the set of months in the year when the average high temperature in Phoenix is less than 10 degrees Fahrenheit. That's an empty set because there's no months. Of the 12 months of the year, they're all going to have an average high temperature greater than 10 degrees Fahrenheit. And so here I just say an empty set can be written as, I can name it, set A is the empty set here. This says set A is the empty set, and this says set A is the empty set. All right, so empty set is just a set with no elements. More concepts before we get into some homework again. We have this lovely symbol that I can never write that well. So this is a set symbol that we're going to use quite a bit coming up here. And that symbol right here, that E, or I guess it's maybe not an E, but maybe it's an epsilon, means the element. And let me talk more about that here in a second. So this little symbolic few symbols right there, I would read this 5 is an element of set A. So I read this as 5 is an element of set A. And what does that mean? That means if you see this notation, 5 is an element of set A, it means that 5 will be in a list if you make a list of all the elements of set A. This symbol means it's not an element. I would read this as 6 is not an element of set A. What does that mean? This means that if you listed all the elements in set A, that 6 would not be in that set. So let me just make up a set here. Here's an example of a set that fits exactly this criteria. So if A was the set 1, 3, 5, 7, ... it would be perfectly correct to say 5 is an element of set A because it's an element, it's a member of the set, and it would also be correct to say 6 is not an element of set A because in the listing of the elements of set A, 6 isn't in there. So this, when I see this symbol, this means either the object or the element is in the set or it's not in the set. And that's how we're going to use it properly. So if I see a set and a number or an element is in the set, we can use this statement to describe that that number is in the set, or we could use this to describe that that number is not in the set. All right, let's go through some true or false statements here. So considering the following statements with regard to set B. B is a set that contains the numbers 1, 2, 3, 4, and 5. State whether the statement is true or false. So 1 is an element of set B. Well, I look at this, I look in set B, 1 is certainly an element of set B, so I'm going to say this is true because 1 is in the list of all the elements of set B. My whole answer is just true. I just put this extra garbage down here to emphasize why it's true. This one says 1 is not an element of set B. Well, that's not good because 1 is an element. This saying 1 is not an element of set B would mean I'd go up to set B and I wouldn't see the number 1. So this is going to be false because this says 1 is not in the list of the elements of set B, but it is in there. So this is false. For this statement to be true, 1 couldn't be in the list. How about this? 8 is not an element of set B. This means if I go up to the set, I'm not going to see the number 8. I go up to the set, I don't see the number 8, so that's a true statement because this says 8 is not in the list of the elements of set B, and it isn't, so that's a true statement. How about this? 8 is an element of B. Well, that's false because 8 is an element of B, says if I go up to set B, I'm going to see the number 8. I don't see the number 8, so that makes this a false statement. All right, still more before we can actually get to our homework. Sorry about that. So In this chapter, we use the set of natural numbers a bunch. I don't know why I use it so much, boy, but it comes up so much in every section in chapter 1. The set of natural numbers is often given the letter capital N, and it contains integers greater than 0. The set of natural numbers, which is the letter N, are the numbers 1, 2, 3, 4, 5, ... Doesn't include negative numbers, fractions, decimals, doesn't include 0. The cardinal number of a finite set is the number of elements in a set. So the cardinal number of a finite set, not of an infinite set, is just the number of elements in a set. The cardinal number of set A is denoted, the little n parentheses A. I'm kind of garbling my words right now, but when I get to the examples, I'll explain this a little bit better. Now I'm just kind of reading. So example, find the cardinal number of set A. The cardinal number of set A is the number of elements in set A. There's 1, 2, 3, 4, 5, 6 elements in set A. The cardinal number is the number of elements in a finite set. The cardinal number of this set, because it has 6 elements, is 6. And I'm going to write this down. I'm going to say n, which means the number of elements in set A, equals 6. The cardinal number of set A is 6 because there's 6 elements in the set. And that's exactly what I wrote down there. Do a little bit more here. Find the cardinal number of set A where the set A is a set of natural numbers less than 8. Well, I need to know what set A is. A is a set of natural numbers. Natural numbers start at 1 and they go all the way to infinity. But for this, A only has the natural numbers that are less than but not equal to 8. So these are the elements in set A. It has the natural numbers 1, 2, 3, 4, 5, 6, and 7. In my answer to this, the cardinal number of set A is the number of elements in set A, which is 7. So I had to kind of list the elements of set A before I can know how many elements were in set A. And so the answer here is going to be the number of elements in set A is 7. And then I'm not putting 8 in the set because I would need the word or equal to include the 8. And then all stuff that I've mentioned. There's everything I kind of said here, and there's my answer. The number of elements in set A is 7. Now we're ready to do some homework. Okay, find the cardinal number of each of these sets. So let's work on 25 and 26. For my 26, find the cardinal number, that is, find the number of elements in set A. B is a set of even natural numbers between 5 and 10 exclusive. Well, the even natural numbers between 5 and 10 are 6, 8, and 10. Because it's using the word inclusive, I'm including the 10. I would include the 5, but it's not an even number, so I'm not going to include it. So B has the numbers 6, 8, and 10. That's not the answer. The question is, what's the cardinal number of B? And the cardinal number of B is the number of elements in set B, and the answer is going to be 3. For your problem 25, your set B has natural numbers between 5 and 10 inclusive. Your set B, it's not even, it's both even and odd natural numbers between 5 and 10, including the 5 and the 10. Your answer is going to be the number of elements in that set, because that's what the set is composed of. The number of elements in your set B is going to be 6. I'll let you do 27. I'll write down an answer in a bit. For my 28, A is a set of odd natural numbers greater than 2. So it starts with 3, less than or equal to 5. So I'm not including the 2. I'm only including odd numbers that are bigger than 2. And I am including the 5 because of the word or equal to. So my set A is just going to have 2 elements. My answer to this, the number of elements in set A, is going to be 2. For year 27, just in case you're getting stuck on what elements are in A, it's even natural numbers greater than but not equal to, so not including the 4, and less than but not equal to 11. So your set doesn't include the 4 because to include the 4 would have to say greater than or equal to. So it's only taking even numbers that are bigger than 4, not including 4. It's going to have 6, 8, 10 in it. And then it can't have 11 because it's odd, and it can't have 12 because 12 is bigger than 11. So this is your set A. The answer for 27, the number of elements in set A, is going to be 3. For my 30, my set A has a set of natural numbers that are less than or equal to 5, and natural numbers start at 1. And my set A has the natural numbers that are less than or equal to, so I'm going to include the 5. My set A is going to have those 5 elements, and my answer to problem 30, the number of elements in set A, is 5. When you go to do your problem 29, 9 is not going to be in the set because I don't have the word or equal to. The difference between my 30 and your 29 in terms of how they're worded, you have the word less than, I have the word less than or equal to. When I made up my set A that I wanted to count the number of elements in, I included the 5. You're not going to include the 9, and your answer for 29, I guess, is going to be that. All right, find the number of elements in set B where B equals the set A, C, E, O, and V. I know the number of elements in set B is going to be 1, 2, 3, 4, 5, because there's 5 elements in set B. For my answer to 32, I'm just going to say the number of elements in set B is 5. For year 31, number of elements in set A is going to be 3. And then for my 34, the number of elements in set D, where D is a set that contains the number 0. The number of elements in set D is 1 because there's 1 element of that set. For your problem 33, the number of elements in set C, you can pause the video if I don't want to ruin the answer for you, is going to be 5. So we're probably at a good point right now where I'm going to stop, and I'm going to break this section up into 2 parts. So the next part, there's not that much to do, but if I include it at the end of this video, not every student's going to watch all the way to the end, and there's some concepts on here that aren't hard, but students miss. So there's going to be a part 2. So this is eventually, this is going to be section 1.1. Part 2 in terms of my video, just because, and you can go jump right to that video right now if you want to, but if you need to take a break, and then get to this whenever you can get to it. But I'm going to stop, and so we're not done with section 1.1. There's going to be a whole nother part which should be a little bit shorter.